Okay, we've got a couple more examples that we want to look at related to solving with trig substitutions. And if we remember, we've got square root of x squared minus 1. So when we look back at our trig substitutions, it looks like that the one we need is this one because it's got the x squared minus, and our a here is again 1. So we have x equals 1 secant of t, which is what we want x to be represented by. So x will equal secant of t. Dx is the derivative of secant, which we have come to learn is secant of t tangent of t. And out to the side, let's go ahead and make this triangle because we'll probably need it at the end. Here's our t and here's our angle. We know that x is secant, and secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so x over 1 would be cosine. So that means that secant is x here and then 1 here. When I solve using hypotenuse Pythagorean theorem for this side, then we would have square root of x squared minus 1, which is what we are using as our substitution, so that is good. Alright, so after that, we're going to substitute in our x's and our dx, and so we have the square root of secant squared x minus 1 over secant of x. Dx is secant x tangent x. And really all of those are t's. We're used to making those x's, so I messed up there, but we're all talking about t's here. So then we have the integral. Okay, the square root of secant squared of t minus 1. I know that that's tangent squared of t, but it's square root, so we have a tangent here. And then we still have our secant, and then secant tangent. Alright, and if we look at that, well, we can still simplify a little bit, so we have the integral of tangent squared of t. We don't know the antiderivative of tangent squared, and it's an even power, so we want to change that to 1 minus secant squared of t. And luckily we do know the antiderivative of both of these pieces. The antiderivative is 1. Of 1 is t. The antiderivative of secant squared is tangent of t. And then all we have to do now is go back to that substitution and figure out what's going on here. So we know that x is secant of t. So when I do t, I have to do it with the angle, which means I'm doing the arc secant of the angle, kind of like on the last problem how I did that. So arc secant of x represented by t. Alright, we're doing tangent. Tangent is opposite over adjacent. So here is our t, opposite is that, adjacent is that. So we know that tangent of t is just the square root of x squared minus 1, and then we have our plus c. So all these problems are really similar. It's just after you substitute it in and see what you get, you have to think a little bit about how to solve it, and then to go back in and substitute. Okay, here we have another problem. This one's a little different because it's not just a 1 there with the x squared, so that's nice. That way you can see an example sort of like that. Notice that it's going to look similar to that first example there. We know that a is going to be 2 since this is a 4, so we know that x is going to be 2 sine of t. Go ahead and find the derivative, which we know is 2 cosine of t. And if we want to go ahead and make our little triangle, we can do that. Here's our t. We know that sine of t is x over 2. Like if I solve that for sine, I get x over 2. Sine is opposite over hypotenuse, so then I know that this would be x and this would be 2. If I use Pythagorean theorem and solve for this side, I would get the square root of 4 minus x squared, which is what we were using as our substitution, so that's nice. It should always come out to be that way. After this, so that means that we are going to substitute in what we have here. So we've got square root of 4 minus x squared, so square that. That would be 4 sine squared of t. And then again 4 sine squared of t. And then dx is 2 cosine of t times dt. Alrighty, so what do we have here? Well, this up here, if you factor out a 4, I'll write it to the side a little bit. We've got 4 and then 1 minus sine squared of t. That's what's underneath that square root. So square root of 4 is 2, we know that. This is cosine squared of t, and then we're taking the square root, so that whole square root represents 2 cosine of t. And then we also have the other 2 cosine of t. And then we've got our 4 sine squared of t. So continuing to simplify, we have cosine squared of t over sine squared of t. To finish this problem, there are several ways to do it. One way that I'll just go ahead and show you real quick, you can take the top and rewrite that as 1 minus sine squared of t. I'm going to go ahead and get rid of these 4's. 1 minus sine squared of t over sine squared of t. Divide it out. And in order to finish that, you would need to know what the antiderivative of 1 over sine squared of t is. 1 over sine squared of t is the same as cosecant squared of t. And we can just use that as another formula. If you look up the formula for the integral of cosecant squared of t, you'll find out that you get negative cotangent of t. And then the antiderivative of negative 1 is minus t. And then we have plus c. So this was just a formula. This was just separating each one, dividing each one by sine squared, and then getting that. So then we go back. Cotangent is the reciprocal of tangent. So I know that tangent is opposite over adjacent. So that means cotangent would be the square root over the x. So this would be negative square root of 4 minus x squared over x. Alright, t again is the angle, so I know it's arc something based on what we let x be represented by. So if I divide by 2, I would get that sine of t was x over 2. So that means that t would be arc sine of x over 2. And then that's all.